Hello everybody, welcome to UGC EPG Pathshala, and today we are into that topic which we all use it so often through Google Maps, that is web-based GIS. Our lecture is on web mapping and web GIS. I am Dr. Seema Mehra Parihar, who has been teaching remote sensing and GIS now for the last 30 years. I've had my training from Indian Institute of Remote Sensing, Dehradun, my experience with a postdoc fellowship in ITC Netherlands, my PhD is on natural resource management from Department of Geography, Deel School of Economics. Let's now go ahead and talk about web mapping and web GIS. The learning outcomes are following. Number one, to understand the relevance of internet in today's spatial decision making. To comprehend the importance of web maps and web mapping. We'll also be able to understand the web GIS and its nuances, advantages, disadvantages, and so on. We'll also be able to visualize the application of web GIS, and that's something so very important. So let's start going with web mapping and web GIS. Web mapping is the process of designing, implementing, generating, and delivering maps of the World Wide Web and its product. While web mapping primarily deals with the technological issues, web cartography additionally studies theoretical aspects. The use of web maps, the evaluation, optimization of techniques and workflows, the usability of web maps, social aspects, and more. Web GIS is similar to web mapping, but with an emphasis on analysis, process of project-specific geodata, and exploratory aspects. Often the term web GIS and web mapping are used synonymously, even if they don't mean exactly the same. In fact, the border between web maps and web GIS is blurry. That's the reason why we have called this chapter as web mapping and web GIS. But before we do that, let's understand that why is it important and urgent to understand web maps and web mapping and web GIS. The focus now is to understand that why today, why are we doing web GIS and why web GIS is so important. Because today internet is everything. Internet of Things, IoTs, was yesterday. Today the future is internet of everything. IoT is the internetworking of physical devices, vehicle buildings and other items embedded with electronics, software, sensors, actuators and network connectivity that enables them to collect and exchange data. Today we are talking about the big data, cloud and the Internet of Things are all part of a continuum. It's hard to think about the Internet of Things without thinking about cloud, and it's hard to think cloud without the analytics as it becomes a buzzword. It's advisable that the integrated network and big data will use advanced analytics to create actionable intelligence with predictive algorithm to program automated smart system with improved efficiencies. Multiple sensors today are there, like cameras, scanners and sensors. They provide data to smart systems in every sphere of life, and that too in real time. Now today we have cities to energy, transport, agriculture, natural resource management to health, etc., etc. That means we are doing so many things together, and we are also having smartphones in our pocket. So all this, in case if it is there, who is controlling? But what we definitely need is that the data usage from different parts should be able to understand the machine language, break down, ordering a replacement automatically before a part actually breaks. So anything that's there is today wanting to have an output that's in real time and at relatively low cost. Of course, some may say that this internet given or internet expectation is a hype. Of course, hype may be in full swing, but cynics would call it a hype. But if we go with the actuals, we may find that everything today is linked with internet. Cisco says as many as 50 billion devices will be connected to the internet by 2020. That is 3 years from now. According to Juniper Research, there will be over 285% rise in connected devices by 2020. 285%. IoT industry is set to grow to $1.9 trillion in size by 2020 as per Gartner estimates, while AT Kerme says IoT will start to impact close to 6% of the global economy in the next 4 years. Needless to say that this kind of next generation market opportunity is pulling in tens of millions in venture funding for startups as well. In 2014 alone, over $1.6 billion was invested into web-based IoT companies by venture capitalists. So in case if this is the scenario today and from 4 years from now, don't you think it's important for us to understand these web maps and web GIS? Of course it is so important. Before we get into that, let's understand what is a web map. Web maps are often presentation media in web GIS, and web maps are increasingly gaining analytical capabilities. A special case of web maps are mobile maps, displayed on mobile computing devices such as mobile phones, smartphones, PDAs, GPS, other devices. If the maps on these devices are displayed by a mobile web browser or a web user agent, they can be regarded as mobile web maps. And if the mobile web maps also display context and location sensitive information such as points of interest, the term location-based service is frequently used, isn't it? And the use of the web as a dissemination medium for maps can be regarded as a major advancement in cartography and opens many new opportunities such as real-time maps, cheaper dissemination, more frequent and cheaper updates of data and software, sometimes personalized map content, distributed data source and sharing of geographic information. It also implicates many challenges due to the technical restrictions, like low display resolution sometimes due to hardware and sometimes due to software also. In particular, with many mobile computing devices, many of which are physically small and use slow wireless internet connection, again there are resolution issues. Then we also come across copyright and security issues. And sometimes you won't believe that reliability issues also exist. And then of course, it's a combination of technical complexity. While the first web maps were primarily static due to the technical restrictions, today's web maps can be fully interactive and integrate multiple media. This means that both web mapping and web cartography also have to deal with interactivity, usability and multimedia issues. So what are the three things? IUM, interactivity, usability and multimedia issues. The advent of web mapping can be regarded as a major new trend in cartography. Previously, cartography was restricted to a few companies, institutes and mapping agencies requiring expensive and complex hardware and software, as well as skilled cartographers and geoinformatic engineers. But with web mapping, freely available mapping technologies and geodata potentially allow every skilled person to produce web maps with expensive geodata and technical complexity. Data harmonization, missing standards are all of course they're there, but being two of the remaining barriers preventing web mapping from fully going mainstream. The cheap and easy transfer of geodata across the internet allows the integration of distributed data sources, opening opportunities that go beyond the possibilities of disjoint data storage. Everyone with minimal know-how and infrastructure can become a geodata provider. You can also become a geodata provider. Who is stopping you? And these facts can be regarded both as an advantage and a disadvantage. While it allows everyone to produce maps and considerably enlarge the audience, it also puts geodata in the hands of untrained people who potentially violate cartographic and geographic principles and introduce flaws during the preparation, analysis and presentation of geographic and cartographic data. We have seen it all. The scale is missing, nothing is not there, you have legend in a wrong place, and all those things are there, but this is happening. Right? So that means web maps are there and everybody is using. You, me, our uncles, our aunts, our children, nephews, nieces, everybody is using. Okay? So it's clear? So now I think is the time. Let's go to another thing. That is types of web maps. The moment we talk of the types of the web maps, first classification of the web map has been made by Menno Krag. Menno Krag was my mentor when I was at ITC Netherlands. Yes. He was the first one to distinguish static and dynamic web maps and further distinguish interactive and view-only web maps. However, today in the light of the increased number of different web map types, this classification needs some revision. Today there are additional possibilities regarding distributed data sources, collaborative maps, personalized maps and so on. Alright. So now let's talk about analytics web maps. These web maps offer GIS analysis either with geodata provided or with geodata uploaded by the map user. As already mentioned, the borderline between analytic web map and web GIS is blurry. Often parts of the analysis are carried out by a server side GIS and the client displays the result of the analysis, and as web clients gain more and more capabilities, this task sharing may gradually shift. Alright. Then we also have, in addition to this, we also have animated web maps. What are these animated web maps? Animated web maps shows changes in the maps over time by animating ones of the graphical or temporal variables. Various data and multimedia formats and technologies allow the display of animated web maps. SVGs, Adobe Flash, Java, QuickTime, etc., all with varying degrees of interaction. Example for animated web maps are weather maps, maps displaying dynamic, natural or other phenomena, and as in the figure you can see in the recent earthquake and the impact map. Trade flows, communication patterns, social studies projects, so on and so forth, so many. Right? So now after animated web maps, we have another type of web maps. Starting with C, we do it together. You guessed it right, collaborative web maps. Collaborative maps are still new, immature and complex to implement, but show a lot of potential. The method parallel to the Wikipedia project where various people collaborate to create and improve maps on the web. Technically, an application allowing simultaneous editing across the web would have to ensure that geometric features being edited by one person are locked, so they can't be edited by other persons at the same time. Also, a minimal quality check would have to be made before data goes public. Some collaborative map projects are Google Map Maker, OpenStreetMap, Wikimapia, MetaMaps, Survey of Wikimedia Map, proposals are there, all these things are there, so they're there, but they're happening, okay. So that's another category. Another category starting with C is the customized web maps, right, customized, they're customized. Web maps in this category are usually more complex web mapping systems that offer APIs for reuse in other people's web pages and products. For example, for such a system with API for Rouse is the Open Layer framework. Yahoo Maps and Google Maps are one examples of that. Then you also have distributed web maps. These are maps created from a distributed data source. The WMS protocol offers a standardized method to access maps on other servers. WMS servers can collect these different sources, reproject the map layers if necessary and send them back as a combined image containing all requested map layers. One server may offer a topographic based map while the other server may offer thematic layer, right? That's one. Another one can be a dynamically created web map, okay. Now what are dynamically created? These maps are created on demand each time the user reloads the web pages, often from dynamic data source such as databases. The web servers generates the maps using a web map server or self-written software. Some applications refer to replication as hypermaps, and one of the example is say Busam Panda by the Indian Space Research Organization, ISRO. Then you have another type of web map called hypermap, hyper, H-Y-P-E-R. Any approach offering the planar presentation of a portion of n-dimensional orthogonal web map structure with the option to choose the area of depiction from the dimensions, right? That's what it is, hypermap. Then you have another category which is called interactive web maps. Interactivity is one of the major advantages of screen-based maps and web maps. I hope you all will agree with it. It helps to compensate for the disadvantage of screen and web maps. Interactivity helps to explore maps, change maps parameter, navigate and interact with the map, reveal additional information, link to the other resources and much more. Technically, it is achieved through the combination of event scripting and DOM manipulation and all these client maps. So now I think now we have seen so many diverse maps, and I think so now you know at least 3 web maps. Alright, I asked you to remember 3 maps. Yes, note them in your copy, we'll revisit them. Okay, now let's look into the advantages of web maps. Web maps can easily deliver up-to-date information, and if maps are generated automatically from database, they can display information in almost real time. They don't need to be printed, mastered and distributed. For example, a map displaying election result as soon as the election is over, it's just there. A map displaying the traffic situation near real time by using traffic data collected by sensor networks. Another is a map showing the current location of mass transit vehicles such as buses or trains, allowing patrons to minimize their waiting time at stops or stations or be aware of the delays in services. Weather maps such as NextRad. So what we need is an additional software and hardware infrastructure for web maps. And this is also cheap. Web server hardware is cheaply available and many open source tools exist for producing web maps. Product updates can easily be distributed because web maps distribute both logic and data. With such requests of loading, product updates can happen every time the web user reload the application. In traditional cartography, when dealing with the printed maps or interactive maps distributed in offline media, CD, DVD, a map update costs serious effort, of course, triggering a reprint or remastering as well as a redistribution of the needs. With web maps, data and produce another update. So it was very difficult. Today it's dynamic. And if web maps are implemented based on open standards, the underlying operating system and browser do not matter at all. Further, web maps can combine distribution data sources. Using open standards and documented APIs, one can integrate mashups now, different data sources. If the projection system, map scale and data quality match, the use of centralized data sources remove the burden for individual organization to maintain copies of the same data set. The download is that one has to rely on and trust the external data sources. Web maps allow for personalization. I hope you'll agree. By using user profiles, personalized filters and personalized styling and symbolization, users can configure and design their own maps. So if the web mapping system supports personalization, accessibility issues can be treated in the same way. If user can store their favorite colors and pattern, they can avoid color combination they can't easily distinguish. Right, the color blindness, so on and so forth. Then another advantage is that web maps enable collaborative mapping. Similar to the Wikipedia project, as I've shared with you earlier also, the web mapping technologies such as DHTML, Ajax, SVG, Java, Adobe Flash, etc. enable distributed data acquisition and collaborative effort. Example for such projects are the OpenStreetMap project, Google Earth community and so on. As with other open projects, quality assurance is very important. However, web maps support hyperlinking to another information on that web. Just like any other web page or a wiki, web maps can act like an index to other information on the web. Any sensitive areas in a map, a label, text, etc. can provide hyperlink to additional information. As an example, a map showing public transport options can directly link to the corresponding section in the online train timetable. It is easy to integrate multimedia in and with web maps. Web maps, we know by now, enable collaborative mapping, and this is of course like a Wikipedia project which I discussed before also. We've got DHTML, Ajax, SVG, Java, Adobe Flash, etc., etc. And of course the OpenStreetMaps and the Google Earth community map are something which we're doing it so very often. So in addition to this, what web maps do is they support hyperlinking to another information on the web. Just like any other web page or a wiki, web maps can act like an index to other information on the web. Any sensitive area in a map, a label, text, etc. can provide a hyperlink to additional information. Isn't it great? As an example of a map showing public transport options can directly link to the corresponding section in an online train timetable. It's easy to integrate multimedia in and with wide maps. Current web browsers support the playback of video, audio and animation, SVG, SWF, QuickTime and so on and so forth. So that means we are now very clear what is a web map, and we are also very clear about the different places where we are using web maps. Let's now talk about 5 essential elements of this web GIS. So now, of course, web mapping and web GIS, I said earlier there's a blur line, but the question is how blur? So now you may be wondering to yourself, what is this web GIS and why are we doing it separately? It seems fairly broad in scope for me. According to ESRI, web GIS is a type of distributed information system comprising at least a server and a client, where the server is a GIS server and the client is a web browser, desktop applications or mobile applications. So web GIS has many advantages, including cases of use, support for uni and updates diverse apps and more, right? So I can say that if I want to take it further, web GIS is a type of distributed information system comprising at least a server and a client, okay? Distributed information system, server and a client, where the server is a GIS server and the client is a web browser. Desktop applications or mobile application. In its simplest form, web GIS can be defined as any GIS that uses web technology to communicate between a server and a client. So from SSP, the term web GIS is being tossed around all over the place right now, but the true meaning of the term may be very different from what you understand it to be. Right? So web GIS explanation, its simplest form, web GIS can be the need as any GIS that uses web technology to communicate between a server and a client. And there are following other few key elements essential to web GIS. Right? First of all, there has to be a server, and server should have a URL so that client can find it on the web. Then the client relies on HTTP specification to send requested to the server. Third is the server performs this requested GIS operation and sends responses to the client via HTTP. The format of the response sent to the client can be in any format, such as HTML, it can be binary image, XML, extensible markup language, or JSON, JavaScript, object notion, and so on and so forth. But the whole idea is client and server should be able to communicate through web. In the document titled A Framework for Deploying Web GIS Application, it has been pointed out that there are 5 essential elements in every web GIS app. And these include number 1, a web application, number 2, digital based maps, number 3, operational layers, number 4, task and tools, and number 5, 1 or more geodatabases. Right? So clear. So now let's talk about web GIS advantages. Do we have any? Of course we have. By utilizing the internet to access information over the web without regard to how far apart the server and client might be from each other, web GIS introduces a distinct advantage over traditional desktop. Number 1 advantage, the most important advantage is it is borderless. It has a global reach. In case if I use this, I may say that a user can present web GIS application to the world, and the world can access them in the computer or mobile device. Somebody may be sitting in a village in India. He can have an accessibility to a small town or any other functional town in USA or in Australia. The global nature of web GIS is inherited from HTTP, which is broadly supported. Almost all organizations open their firewalls at certain network points to allow their requests and responses to go through their local networks, therefore increasingly accessibility. Next is a large number of users in general. A traditional desktop GIS is used by only one user at a time, right? But out here through WebGIS, large number of users can be used. While a WebGIS can be used by dozens or hundreds of users simultaneously, thus WebGIS requires much higher performance and scalability than desktop GIS. I hope you will agree. Another third very great advantage is better class platform capability. Majority of WebGIS clients are web browsers. Internet Explorer, Mozilla, Firefox, Apple, Safari, Google Chrome and so on and so forth. Because these web browsers largely comply with HTML and JavaScript standards, WebGIS that relies on HTML clients will typically support different operating systems such as Microsoft Windows, Linux, Apple, Mac operating system and so on. Another advantage, another major advantage that I see in WebGIS is low cost. Low cost, what I mean by low cost is an average by the number of users. The vast majority of internet content is free of charge to end user, and this is true of WebGIS. Generally, you do not need to buy software or pay to use WebGIS. Organizations that need to provide GIS capabilities to many users can also minimize their costs through WebGIS. Instead of buying and setting up desktop GIS for every user, an organization can set up just one WebGIS, and this single system can be shared by many users from home, at work or in the field. So good, na? Sometimes you may not be wanting to go to work, you can be at home and still work. For me, the most important advantage of this WebGIS is, and this I am telling all of you, the ones who are listening to me and who are participating in this lecture, is it's easy to use. Desktop GIS is intended for professional users with months of trainings and experience in GIS. WebGIS is intended for a broader audience, including public users who may know nothing about GIS. They expect WebGIS to be as easy as using a regular website. WebGIS is commonly designed for simplicity, intuition, and convenience, making it typical much easier to use than desktop GIS. So what are the words that I use? S, simplicity. I, intuition. C, convenience. In addition, another is the unified updates, another advantage. For desktop GIS to be updated to a new version, the update needs to be installed on every computer. Though for WebGIS, one update works for all clients. And this ease of maintenance makes WebGIS a good fit for delivering real-time information. Another advantage is diverse applications. Unlike desktop GIS, which is limited to a certain number of GIS professionals, WebGIS can be used by everyone in an enterprise as well as the public at large. And this broad audience has diverse demands. Applications such as mapping, celebrity homes, tagging, personal photos, locating friends, displaying Wi-Fi hotspots are a few of the so many current examples of WebGIS. Crowdsourcing nowadays, the big thing, is using WebGIS. Big data is using. And these characteristics reveal both the advantage and challenges facing WebGIS. For example, this easy to use nature of WebGIS stimulates public participation. But it also reminds you to take into account internet users who have no GIS background. Therefore, what happens? Conversely, supporting a large number of users require WebGIS to be scalable, right? So, in case if data store scenario, in case you look at for image services, if we look at it, we need to register the data with the server, and this implies that you need to update it so very often. And when you publish this data, you want to be sure that the server has access to all the content managed by the Mosaic dataset. So you must set the data store and prepare the Mosaic dataset correctly. So important. And so therefore, we can have different scenarios when using Mosaic dataset, since a Mosaic dataset reference data that can be designed anywhere as long as it can be read, right? So you need, if you want visible frontal showcasing of your web map, you need to have somewhere in the background that Mosaic dataset. So what are the different scenarios? Number one, scenario one, all data is on a shared location. This is probably the best data organization structure. Every data is available for everybody. Scenario 2, all data is duplicated. In this scenario, your data is stored in two locations, one accessed by the server and one you connect to the catalog window. Scenario 3, there is no registered data allocation. Like scenario 1, this also is uncomplicated because you don't have to worry about where any of your data is and if the server can or can't access it or the correct version of it. In this scenario, all the data is packaged and moved to the server when it's published. Okay? Scenario 4, only the source data is in a registered location. In this scenario, the source data location is not the same location as the mosaic data set. This source of data is location can be shared or duplicated, right? So that's something which is so very important. That means, so we can have these four scenarios where we can have different data sets. Another example which I like to share with you is of an Indian context. Bhuvan portal is there. You can use data. But one of the most important and a very nice portal which I want to refer with all of you is a water resource information system. Water resource information system, in case if I look at it. Now let's look at the contextualize this in the context of India. It may be a Bhuvan portal from NRSC, and we have so many data sets which are there where we can play with the data on the web. Another very good example which I really am very fond of using and is a web GIS portal, a great example from India, is a water resources water resource information system, WRIS. In India, this water resource information system or this web GIS aims as a single window solution for comprehensive, authoritative and consistent data and information of India's water resources along with allied natural resources in a standardized national GIS framework with tools to search, access, visualize, understand and analyze the data for assessment, monitoring, planning, development and finally integrated water resource management. The project has been jointly undertaken by CWC, MOWR and NRSC and ISRO and Department of Space, and this started off in 2009. My request to each one of you, if you're studying web GIS, please go to WRIS. Just type in the Google search index, just type WRIS and you will get this water resource information system. Just look at it and you'll be able to understand what is web GIS. And based on the requirement and data availability, the India Water Resource Information System, web GIS, has 12 major info systems, 36 info systems, including 95 layers, classified under 5 major groups. One group is a watershed atlas, second is administrative layers, third is water resource projects, fourth is thematic layers, and fifth is environmental data. The main layers developed under India WRIS are basin, sub-basin, watershed, river, water body, urban and rural population extents, dams, barrage, weir, aqueducts, canals and command boundaries, etc. And these spatial layers have large number of attribute data of 5 to 100 years depending upon a theme. All unclassified data of Central Water Commissions and Central Groundwater Board groundwater data is available in this portal for free download. Imagine the data that you all run for. It's all here. The information system has dedicated sub-information system for various components of surface water, groundwater, hydrometer observations, water quality, snow cover, interbasin transfer links, land resources, socioeconomic parameters as well as infrastructure and other administrative layers. The India WRIS web GIS has special modules for live telemetry data and a reservoir model with daily level and storage data of reservoirs. Automatic map generation and automatic report generation module can cater the need of area specified maps and reports. Customized maps can be generated using Create Your WRIS module. India WRIS web GIS has all the map viewing and other capabilities including saving printing facilities. In addition, WRIS website, surface water quality sub-info system, groundwater quality sub-info system, head office sub-info system, reservoir module, telemetry module, snow cover glacier sub-info system, so much is there. It's a beautiful example. I think so, one of the best one in the world. I think so you all now are gearing up in using WebGIS. Let's summarize what we studied today. We studied today many things. The keyword was WebGIS. And we also realized that Internet of Things, IoT, was yesterday. Today the future is Internet of Everything. And the 5 essential elements in every WebGIS apps include a web application, digital base maps, operational layers, tasks and tools. Then there is a thin line between web mapping and WebGIS. We need to use it correctly. It is not a hype and it's borderless with global reach. Cynics would only call it a hype, but in reality is, if we go by the figures, the hype is in full swing. And if we go with the Cisco, if as many as 50 billion devices will be connected to the internet by 2020, and there will be 285% rise in connected devices, and the industry is going to grow by $1.9 trillion, and the impact is going to be 6% of the global economy. Needless to say, let's all gear together and let's all work together and let's all learn how to use WebGIS. Enjoy WebGIS. I definitely enjoy this. I enjoy GIS. I enjoy all types of GIS, but WebGIS is future. Yes, WebGIS is here to stay, like open source GIS. Enjoy making maps, enjoy making web maps, and love the subject. Thank you very much.